would matter. So Julian's problem was there are 10 students. So we'll say in a class of 10 students, choose a president and a vice president. Right? Okay, so what would the setup be then? What would I get ready to type into my calculator? 10P2. Good. Now, what does the C stand for? Combination. And in a combination problem, order does not matter. And can somebody give me an example of a problem that would be a combination problem?
There's like 3 identical prizes.
So in a class of 20 students, we're giving 3 identical prizes. Now, why does the fact they're identical matter?
Because they don't really care like which order they get.
Exactly. If you know the prize is going to be a pencil, you don't care if you get picked first, second, or third, right? You're going to get a pencil either way. So that would be 20C3. Everybody remember that from yesterday? So we use P's and C's when we have a group of people or a group of things and we are choosing a subset out of there. So I have 20 students and I'm going to pick 3. Or I have 10 students and I'm going to pick 2. Or I have 52 cards and I'm going to pick 5. That would be 52C5. We'll talk a little bit more about that in a bit. What else did we talk about yesterday? We talked about a lot of things yesterday. That's why I want to recap a little bit before I give you a little quizzy pool. So what else did we talk about yesterday? Besides P's and C's, what else? What? Factorial. Now, factorial, what's the symbol for factorial on your calculator? The exclamation point. And give me a problem where we use factorials. What was an example of a problem? You can look at your note sheet. What was the example, Harry?
Like, I remember one of the note sheet was how many ways can you arrange 5 books on a shelf?
Exactly. This situation is how many ways can you arrange, and it can be 5 books on the shelf, it can be 9 people in a row, it can be 8 letters of a word, it doesn't make any difference. How many ways can you arrange, I'll just say 5 books on a shelf? And that would be 5 factorial. So remember the ones we did with words, where I think one of our words was Chevy? So how did we figure out how many ways we could arrange the letters of the word Chevy? How many letters there were, so it was 5. So the answer was 5 factorial. When we did my name, Lisa, how many ways? 4 factorial. But what do we have to be careful of with some words? If they have a duplicate letter. So remember how we handle that? So let's look at Jamal's name. Did I spell that right, Jamal? Now, that has how many letters?
2.
No, how many letters? That's 5 letters. So we would start with 5 factorial. We always start with how many letters we have. Okay, I don't care if they're duplicates or not. You start with how many letters you have. But then, because he has 2 A's in his name, we will have to do what? Divide by 2 factorial. Do you remember that? Everybody okay with
Can you
that?
just leave it like that though?
No, then you type that in on your calculator. 5 factorial divided by 2 factorial. Now, speaking of typing in on the calculator, the P's, the C's, and the factorials are all located in the same place on your calculator, right? Who remembers how to get to them? What do we have to do to get to the P's, C's, and factorials? We go to math, hit your math button, which is right there in the first column, and then you click all the way across to where it says prob, right? And then you'll see in the list, and you just click down and pick the one you want. Okay. Did we talk about anything else yesterday? That pretty much recaps it, I think. Can you think of anything else? Oh, yes. Okay, we talked about the difference in a problem between an and situation and an or situation. Okay? So let's do an example of that. Let's suppose that I go down to the cafeteria and I'm going to have a sandwich and a dessert and a drink. Okay, this is going to be my lunch. And the cafeteria offers 5 different kinds of sandwiches and 3 different kinds of desserts and 2 different kinds of drinks. Okay, so I go down to the cafeteria and I'm going to pick one of each of these. And I have all these different choices. How many different lunches would be possible if I'm going to pick a sandwich and a dessert and a drink? 30. I would times them all together. Remember the jumper shirt example? Same thing. I'm going to wear a jumper and a shirt. So if I have 8 jumpers and 10 shirts, that's 80 outfits. If I have 5 and 3 and 2, that's 30 different lunches that I could have. Okay? Now that's a little different situation than if we have this. Let's say we go down to the ice cream parlor and they have 3 flavors of ice cream. And I'm going to get 1 scoop or 2 scoops. Okay, so I go down there. Let's say I'm going to get a 1 scoop ice cream cone. How many different 1 scoop ice cream cones could I have if they have 3 flavors? 3, right? I could get chocolate, vanilla, or strawberry, right? And I'm getting chocolate, but you'd have 3 choices, right? Now, what if it's a 2 scoop? Now, wait a second, that's a little bit different. How many choices do I have for my first scoop? 3. How many choices do I have for my second scoop?
3.
No, I still have 3 because I could get chocolate, right? Which I would have. So there we go. So that's 1 scoop and another scoop. So I would multiply those and get 9. So there's 9 different 2 scoop ice cream cones I could get. There are 3 different 1 scoop ice creams. So if I'm going to get one or the other, how many choices would I have altogether?
6.
What would I do with these 2 numbers?
You'd add them.
I'd add them. So altogether there would be 12. When it is scoop and scoop, we multiply. When it is 1 scoop or 2 scoops, we add. Okay? All right, let me do one more example like that to make sure that that's clear. Let's say you're going to have a 5-card hand from a standard deck of cards. And you want to get 2 diamonds and problem 1. Problem 2 is, I want to get 5 hearts or 2 diamonds and 3 spades. Alright, so let's look at this one. I want to get 2 diamonds and 3 clubs. Okay, so think of a deck of cards. If I split it up, how many would be in the diamond pile? How many cards would be in the diamond pile? No, not 4.
11.
Oh my. There's 52 cards all together in the deck. 52. And they're divided up into 4 suits. So there's 13 diamonds, clubs, hearts, and spades. Okay? So there's 13 of each. So there are 13 diamonds, and we're going to pick 2 of them. So here's my diamond pile. There's 13 here, and I'm going to pick 2. Now, how many are in my club pile? 13. And this time I want to pick 3. Now, what will I do? I know I can type both of these numbers in on my calculator. What will I do with those 2 numbers? Multiply them. Very, very good. Now, 5 hearts. What would that look like? 13C5. Again, there are 13 of each suit. Clubs, hearts, spades, and diamonds. What would 2 diamonds and 3 spades look like? We kind of already did that. What would that look like? 13C2 times 13C3, because it's 2 diamonds and 3 spades. Now you can type that in on your calculator and get a number. You can type that in and get a number. What are you going to do with these 2 numbers now? You're going to add them because of the OR. Trey.
Where do you get the 13?
Okay, there's 52 cards in the deck, divided into 4 suits. Spades, hearts, clubs, diamonds. Have you ever seen a deck of cards?
I have.
Okay. So 15 divided by 4 is 13. Or 52 divided by 4 is 13. There's 13 of each suit. All right, so do you understand the difference between and or? Okay. All right. One practice problem, then we're going to take a little quiz, okay?
Whoa.
Yep. That's what we've been practicing for. Sorry you haven't been paying attention. Here's the practice problem. I have 20 students, and I am going to award a first, second, and third place prize. How many ways can I do that? There are 20 students, first, second, and third place. How many ways can I do that? You can just tell me, what do you think the answer is, Savannah?
Wait, are all the prizes
8,000.
Nope, first prize, second prize, and third prize. They're different.
How many of them?
They're all different.
Oh,
So do you want us to put this in our country?
20P3, Katie O'Neill says, and she was right. 20P3. Why is it 20P3? There are 20 kids. I'm picking 3, and the order matters. You want first prize.
On the test, you want us to write down 20P3, then you want us to put it in our calculator?
You'll work it out. You'll work it out. So Blake's question was, do you want me to work that out on my calculator? And the answer is yes. Obviously, if you do not have a calculator, then you're not going to be able to work it out, and you're going to lose that little bit of points. You're not going to lose full credit, obviously, if you set it up right, but you're going to lose some.
Wait, how do you set up 20 PC?
20P3?
I mean,
Yes, we just talked about it.
no, I know how to write it, but I don't calculate it.
We talked about it. You type in 20,
Yeah.
then you go to math, prob, click down to NPR, and then put in 3. And then hit equals. And then we'll give you the answer.
That's 6,000.
Okay? everybody to take out a half sheet of paper. And it's Erica's birthday. That means we have a big
First, second, third grade.
I was like, okay, I'm sorry.
Alright, there is no borrowing calculators from each other. That does not fly.
I was just like, don't get one because I feel really like nervous.
Okay, here we go. Everybody's ready?
Yeah, I know. They'll be like, really?
What? You know how to do it on the second one?
All right, here we go, everybody. We are. Jennifer, you need to move over. Mr. Devine, can you come up here? All right, so it's real short. It's taking us forever to get ready, but it'll go short. It'll be fast. All right, listen carefully. Listen carefully. Question number one. You can write the question if you want, or you can just work out the answer if you think you know. Number one. How many ways can I arrange 8 students in a row? How many ways can I arrange 8 students in a row? 8 students in a row. How many ways can I arrange them? One more time. How many ways can I arrange 8 students in a row? Number 2. How many ways can I arrange the letters of Julian's first name? And he's going to spell it for us. So how many ways can I arrange the letters of Julian's first name? Julian, spell it loudly and slowly, please. Julian. How many ways can I arrange those letters? One more time. How many ways can I arrange the letters of Julian?
Should we count the L's as different letters?
I'm not answering that question. We talked about this. Number 3. I have 12 students. I need a committee of 4. A committee of 4. How many ways can I choose a committee of 4 from my 12 students? I need to choose a committee of 4 from 12 students. How many ways can I do that? 12 students. And number 4. I need to make my schedule for next year. I need to pick one math class, one science class, and one English class. There are 3 science choices, 5 math choices, and 2 English choices. So 3 science, 5 math, 2 English choices. 3 science, 5 math, 2 English choices. I need to pick one of each. How many ways can I do that? I need to pick a math and a science and an English. How many ways can I do that? One more time. There are 3 science, 5 math, 2 English. I need to pick one of each because I have to take a math, a science, and an English. How many ways can I do that? DJ, please don't look at his paper. Turn around. Turn around, buddy. All right, Erica, let's have your bonus, dear.
1 plus 1.
1 plus 1, that's worth 4 points. Well, hopefully everybody gets it right. All right, pass your papers in. Let's see how you did. We're going to load this right now. All right. Your name's on everybody's paper today. All right, here we go. Let's see how we did. Number 1. Oh, who didn't follow directions? Number 1. How many ways can I arrange 8 students in a row? 8 factorial. And work it out, and I don't know what that is, but it's some big number, 8 factorial, right? Okay. Next question. How many ways can I arrange Julian's name? What did you start with? Julian. Did you start with 7 factorial?
Yeah.
And then what did you do?
Divide by 2.
Divide by 2 factorial. So in your calculator, you get 7 factorial divided by 2 factorial. Right? Next question. I have 12 students. I'm picking a committee of 4. How did you set that up? 12C4. 12C4. Why is it a C and not a P? Because if you're just making a committee, it doesn't matter what order you get picked in, right? So I don't know what number that is, but you type in your calculator 12C4. And then the last question was, I have 3 science choices, 5 math choices, and 2 English choices. I have to pick one of each because I'm taking a math and a science and an English. How many different schedules could I have? And the answer is 30. 5 times 3 times 2. That's the jumper problem. How many outfits can I make? How many schedules can I make? All right, how many perfect papers did we have? That is wonderful. If you didn't get a perfect paper, you understand what you did wrong?
I need a calculator.
All right, get your note sheets out. Get your note sheets out. We're going to go over one thing quickly in the notes, and then we're going to look at your homework to see if you have any questions there. Okay? So on the note sheets, I need you, we're not going to start with number 1 right now. we're going to skip over and look at number 3, which is on the back of page 58. On the back of page 58, we're looking at number 3, the one that says evaluate by hand. Now, this notation is new to you, so I want to make sure we talk about it, okay? 7.3 is a different notation for 7C3. Combinations are used so much that sometimes instead of writing it out this way, all they do is write this. Now, I know you could type it in on your calculator. Well, at least I hope I know that. What this says is evaluate by hand. So I need to help you figure out how we're going to evaluate this by hand. It's real simple. This equals 7 factorial, so the big number, the first number, divided by 3 factorial, the little number, the second number, and 4 factorial. There's always 2 things in the denominator. Now, the 3 factorial is easy. I mean, obviously there's a 3 there, okay. Where do you think I got the 4? 7 minus 3. Now it says evaluate by hand. Okay, now wait a minute. What does that means no calculator. What does 7 factorial mean? 7 times 6 times 5 times 4 times 3 times 2 times 1. What does 3 factorial mean? 3 times 2 times 1. And 4 factorial means 4 times 3 times 2 times 1. Now, do you see what's going to happen? There's a lot of arithmetic here, I agree, but a bunch of stuff will cancel. Won't all of that cancel? And what's 3 times 2 times 1? 6. So that will cancel with that. And all that's left is 7 times 5, which is 35. Now, go ahead, and those of you that have calculators, type in 7C3 and see if you get 35. Did you? Yeah. Okay, so when I look at the next one, and it says 8C3, all right, what will the setup be for 8C3 if I'm doing it by hand? If you are using your calculator, you don't worry about any of this. You just type in 8C3. But if you're doing it by hand, it would be 8 factorial divided by 3 factorial times 5 factorial. Right? How did we get the 5? 8 minus 3. So then we say, okay, 8, 7, 6, 5, 4, 3, 2, 1. 3, 2, 1. 5, 4, 3, 2, 1. And then you just start canceling. Whatever you want to cancel. So I'm just going to cancel all this. And the answer should be 56. Now sometimes kids look at ones like C and freak out because those are big numbers. Now here, look. That would be 100 factorial over 98 factorial 2 factorial. Everybody in agreement? Now, I'm with you. I do not want to write out 100 factorial, but I want you to pay attention to what's going to happen. Maybe you've already seen it or figured it out. This is going to be 100 times 99 times 98 times 97, dot, 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 dot.
All of those will cancel.
But since it's over 98, 97, dot, 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 won't all of that cancel out?
Yeah.
So I don't have to worry about writing it all out. It's all going to cancel. But I do have an extra 2 times 1 down there. So my answer will be, well, let's see, 2 will cancel into here 50 times. So my answer is going to be whatever 50 times 99 is.
4,950.
Okay, I'll take your word for it. 4,950 is the answer. So I do have to do a little bit of multiplication, but it's not bad.
Will the bottom number ever be like bigger than the top?
It can't be. That's impossible. Because remember, Savannah, this says I have 8 kids and I'm picking 3 at a time. You can't have 8 kids and pick 10 at a time. That doesn't make any sense. So that will never happen. Never.
And you multiply the
Okay, let's do one more here. What's the setup for D going to be? 11 factorial divided by 6 factorial, 5 factorial? So 11 times 10 times 9 times 8 times 7 over 5, 4, 3, 2, 1. Now, how come I did that? Because from here on, what am I going to have? 6, 5, 4, 3, 2, 1, which is going to cancel with this guy. So I just kind of did that in my head. Everything from here on is going to cancel with him. Do you see that? Now I still have this down there. Now you can cancel this any way you want. I see a 4 and a 2, so that'll take out the 8. I see a 3, which will go into my 9. I see a 5, which will go into my 10. Now that's the way I canceled. You could cancel other ways. So I have 11 times 2 times 3 times 7. So I have 66 times 7. The 8 went away with the 4 and the 2.
Did you use the 2 twice? Oh, no, you used the 5.
The 4 and the 2 went into the 8, the 3 went into the 9, and the 5 went into the 10. Is that better? So I got 462, but that might be wrong. Is that okay with everybody? All right, there's one more. Do it on your own. Do 10C7 on your own. Then we're going to look at your homework. I got 120. So everybody's good with that? So if you walk in here on Monday and you have a little quiz like this, you'll have no issues. All right, did anybody have a question about one of the homework problems in the book? Any problem with homework in the book? Craig, what are you doing back there? Any questions about your homework in the book? All right, your assignment for tonight's on Schoology. It's in the book again.